Okay.
Well, we can't do it.
I can't do it yet.
Okay.
Okay, so now, let's hope this works for her and for anybody else that wants to look at it again on, I'll probably put it on Canvas, yeah. Or I'll try to. Probably have to do a YouTube link through Canvas. Anyway, I'll try to do that. Do what?
Just keep talking. I'm looking.
Okay. All right. The identities in section 5.2 are going to be the same identities that we used in section 5.1. You are going to be using, again, the reciprocal identities, your quotient identities, your Pythagorean identities, but you are not going to use these negative angle identities when we get in section 5.2, okay? So these are in 5.1 and in 5.2. All right. These identities, I hope you know them or remember them because they're going to come in handy. All right, what we're going to do today is sort of like what we did the other day. Remember when we had trig expression, something equal to something, and we took it and we tried to make one side match the other? We're doing more of that today. They're going to involve a few more steps perhaps than we did the other day. So what we're going to do is I'm going to go through their hints and then I'm going to work some examples and hopefully it'll start to catch on. All right, so let's look at their hints for verifying the identities. All right, first of all, it said learn the fundamental identities given in section 5.1. Those, again, are the reciprocal identities, the quotient identities, and the Pythagorean identities. Those are the ones that we're going to be using. Also, be aware of the equivalent forms, and I believe I gave you some equivalent forms the other day that you could write on your sheet. For example, sine squared theta is equal 1 minus cosine squared. That is an alternative form of that basic one that says sine squared theta plus cosine squared of theta is equal to 1. So be aware of any alternative forms. Okay? Now when you're working these identities, another hint is try to work with the more complicated side. All right, sometimes it's hard to tell which is the more complicated, but pick the one you think is more complicated. If you cannot think of anything else to do, number 3 is a great hint. It said change everything in your equation to sine and cosine and then simplify the result, because sine and cosine are easier to deal with than, say, a secant or a cosecant or a tangent. So that's a really helpful hint. All right, hint number 4 has to do with algebra. Sometimes you may have to factor some of these trig expressions. They factor like they did in college algebra. Ooh, I know you hate factoring, and we all do, but I'll go over some in a minute where we're going to factor. But these are the forms for factoring: the difference of cubes, the difference of sums, and the product of sums. I meant the sum of cubes. And here's an example of something that could be factored. All right, again in algebra, sometimes you have to add fractions and get a common denominator. Now remember, when you get a common denominator, let's say you want to add these two fractions right here. You have 1 over sine plus 1 over cosine. The common denominator is both of these. You have to get sine and cosine on the bottom of both fractions. Now here's the correct way to do it. You have 1 over sine in this first fraction. You need to get a cosine on the bottom. So you also multiply cosine on the top. So that fraction now has got the correct denominator. In this second fraction right here, you already have cosine. What you need is a sine in the denominator. So you multiply times sine in the numerator. And then once these have the same denominator, you can combine them into one fraction. Cosine theta, sine theta is on the bottom. On the top, you have 1 times cosine, which is cosine, plus, that plus sign comes right there, 1 times sine, which is sine. So when you add fractions, remember you have to get a common denominator. Okay? As you're looking for substitutions to make in these problems, keep in mind the side that you are not changing. Always keep looking back to what you did not change, because that's where you're trying to get. And you also look for something that relates two sides of your function. What do these two things have in common? Well, they say try to think of an identity that relates a tangent to a cosine. And what they thought of was, in this case, since the secant is 1 divided by the cosine, and since secant squared of x is tangent squared plus 1, you might want to use your secant function to relate the two sides of the equation. So you're looking for things that will relate the sides that you're working on. Okay? Now, one last hint before we get started. If an expression has something like 1 plus sign in the problem, then you can multiply the numerator and the denominator, both of them, by 1 minus sign, and that gives you 1 minus sign squared. Now I want you to see that. If you multiply 1 plus sign of x times 1 minus sign of x, if you FOIL that out, you get 1 minus sign x plus sign x minus sign squared of x. I've just FOILed it out. These two middle terms zero out, and you wind up with 1 minus sign squared. And this is where, if you're familiar with your identities, you know that this is the Pythagorean identity rewritten. This is actually the cosine squared of x. So you can take that and you can simplify it all the way down to cosine squared, which might come in handy in your problem. So cosine squared of x goes in this blank. And I think we're going to work a problem in a minute that's going to have this, we're going to do this in there in it. All right, remember, it does not matter what your high school trig teachers told you. This is not like solving an equation when you have one of these expressions. You cannot move something from one side of the problem to the other. You do not cross your equal sign. You are not solving for one of the trig functions. You are trying to prove the equation, and that is different than solving the equation. So don't try to solve it, okay? Alrighty, so now we're going to work through some examples, and I hope that you'll sort of catch on to what we're doing. Alright, I'm just going to scratch out working with one side of the problem, because it doesn't matter if you work with one side of the problem or two sides of the problem. What you do, though, is I draw a line to remind myself that I cannot take anything that's on this side of the equation over to the other side of the equation. What we need to think about is how we can simplify this side that's full of secant, sines, and cosines down to tangent. I will say there is more than one way to work every one of these problems. Your job is to see what you see and then try to go with it. Now, one thing that comes to mind is we could change everything to sine and cosine. That was a hint. Another hint is that we could do the algebra. And I know the algebra would involve distributing and getting rid of your parentheses. So why don't we do that first, and then we'll do something else. So let's distribute first. When you multiply, you're going to get secant of theta times sine of theta. All right, then distribute secant times cosine, secant times cosine. All right, so we did some algebra. All right, now, if you don't see anything else to do, maybe you want to change everything to sine and cosine. So anything that's already a sine and cosine, leave it alone, but change everything else. So secant You could use your reciprocal identity, and that would become 1 over the cosine of theta. Leave the sine of theta alone. Plus, the secant of theta is 1 over the cosine of theta, multiplied times the cosine of theta. Now, since you've got fractions, if you want to put these fractions over 1, you can. Now, when you multiply fractions, you multiply the top ones together. So 1 times sine gives me sine theta. Cosine times 1 gives me cosine theta. Plus, over here, what happens with this? 1 over cosine and cosine times 1. Right, those cancel, and I'm left with 1. All right, so there's my 1. I've got part of what I needed. Look at sine over cosine. Isn't that a quotient identity? It is. Sine over cosine is the tangent. So this is tangent theta plus 1, and it matches what you were trying to get over there. Okay, so this is the idea. You work one side till you get to the other. Okay, look at another one. Again, I'm going to scratch working with one side, because if you want to work with two sides, it is fine. Again, draw my line. All right, this time, what do you see? I see several things. I'll tell you what I see. I see the distributive property, but I also see this right here reminds me of a Pythagorean identity, because I've got tangent squared plus 1. And it is, according to my identity sheet, is the secant squared. So what I'm going to do, instead of distributing, I'm going to replace this right here with the secant squared. It does. And you're just left with cotangent squared of x multiplied times the secant squared. And I don't have to distribute anything. All right, but look where you're trying to go. You're trying to get a cosecant. So now, I'd probably change these both to sine and cosine, because I like those better. All right, now remember, I told you with your quotient identities, if cotangent is cosine over sine, then cotangent squared is cosine squared over sine squared. So I'm going to replace this one with cosine squared over sine squared. And I'm going to replace secant squared. I can also square my reciprocal identity. Secant squared is 1 over cosine squared. Are y'all following what I'm doing? All right, I'm multiplying fractions right here. What happens? Doesn't something simplify? That cosine simplifies with that cosine. I'm left with 1 on the top, and I'm left with sine squared x on the bottom. Look where you're trying to go. What is 1 over sine squared? It is cosecant squared, because that's the reciprocal. 1 over cosecant squared, and there is simplified again. Questions? I heard that time. Okay. All right, here's another one. And again, it doesn't matter if you work with one side or two sides, so I'll scratch that out. It doesn't really matter. All righty, and this is what we've got. Tangent squared over secant squared equals 1 plus cosine times 1 minus cosine. I'm not even sure which side looks more complicated, because one of their hints was who was the most complicated side. They both look pretty raunchy to me. But maybe FOIL this out, get rid of those parentheses. Let's do that. So let's FOIL that out. That's going to be 1 minus the cosine of t plus the cosine of t minus cosine squared of t. All right, these middle terms zero out, and I have 1 minus cosine squared of t. And isn't that one of my Pythagorean identities rearranged? 1 minus cosine squared is the same thing as sine squared, isn't it? So I would probably replace that with sine squared of t. Can y'all all follow that down to this point? Okay, now I'm pretty much stumped on this side. I can't think of too much else to do with that sine squared. So now I think I would jump over here, yeah. I sure would. On this side over here?
Like, when we're doing the fire stuff,
Mhm.
we can go always go to the other side.
Just go the other side,
Okay.
because that's exactly what I'm fixing to do, because I'm kind of stuck right here. So yeah, then just jump to the other side, and if you can get to, let them meet down here in the middle, then you've proved it. So, all right, tangent squared. I'm going to change that to sine squared of t over cosine squared of t. I'm using my reciprocal identity. Divided by, all right, secant squared is 1 over cosine squared of t. All right, fraction divided by fraction. This is that keep, change, flip thing to simplify. So you keep sine squared t over cosine squared of t. Whoops. You change it to multiplication and you flip this fraction upside down over 1. And now you're multiplying, so what happens with your cosine squares? They're canceling out, and you're left with sine squared over 1, which is sine squared of t. And since you got both of these sides simplified to sine squared, they match, and you've proved it. Question? Is there a question? Okay, are we ready for another one? Okay. These are kind of progressively getting a few more steps in them. I don't know if you kind of noticed that, but you have. Thought perhaps you had. All right, don't get frustrated. It's so easy to get frustrated. Keep going. Just keep going. Trust yourself. Use legal algebra. Make sure everything you do with algebra is legal, and make sure your substitutions are legal. All right, this next one, we've got secants and tangents and sines and cosecants and anyway, we've got a bunch of stuff. And again, both sides look equally complicated to me. But this is where I'm going to use, I believe it is their hint number 6. And I'm going to show you why I would do this. Look at the two different sides of this. This numerator and this denominator are exactly the same except for the sign between them, right? So somehow I've got to get a secant x minus tangent x in my denominator. So what I'm going to do is their hint number 6. I am going to multiply the top and the bottom of this fraction by secant of x minus tangent of x. I'm going to take secant minus tangent, secant minus tangent. As long as you do it to the top and the bottom, you're fine. Right. On the numerator, I'm going to FOIL this out. So foiling secant times secant, let me get some another room. That's going to be secant squared of x plus the secant of x times the tangent of x minus the tangent of x times the secant of x minus tangent squared of x all over my denominator. I'm just going to leave it for a minute as sine of x over secant minus tangent. Okay, did y'all follow what I did? I foiled at the top and then just left the bottom. I rewrote it. All right, on the top, some of this should zero out. Plus secant tangent minus secant tangent cancels out. And I'm left with secant squared of x minus tangent squared of x, all divided by the sine of x times the secant minus the tangent. All right, so I haven't really used any identities so far. All I've done is algebra. Did y'all follow that? All right, look carefully at the top identity. Secant squared minus tangent squared. Again, when I see those things squared, I sometimes go with Pythagorean identities. Is that a Pythagorean identity rearranged? Look at this one. If I have 1 plus tangent squared theta equal to secant squared of theta. If I subtract tangent squared, then I get 1 is equal to secant squared minus tangent squared. Isn't secant squared minus tangent squared what I've got on the top right there? So it's equal to 1. So that right there can be replaced with 1. Sine secant minus tangent. All right, you still with me? Another one of their hints. Keep in mind where you are trying to go. You are trying to go from here now to this. Well, here's my secant minus tangent, and here is a secant minus tangent. I need a cosecant. But what is 1 divided by sine? What is that part right there? Isn't that cosecant? So this right here is cosecant. And I'm left with secant minus tangent on the bottom. And it matches. Yes, because, all right, that's a good question. Because when you have, this is multiplied, right, on the bottom. This is actually the same thing as 1 over the sine times 1 over secant minus tangent. Like that. Whoops. And 1 over sine is your cosecant. Multiplied times 1 over the secant minus tangent. Which is actually the same thing that that is right there. So because it's multiplied right here, you could split it apart. Does that make any sense at all? That is cosecant. And my hint to start off with was because these were just alike except for the signs between the plus and minus. Other questions before we work their last example? Okay. Oh my. Example 5. Verifying identity. They say work with both sides, so I'll just leave that there in case we want to work with both sides. All right, you've got cotangents, cosecants on one side. You've got cosines and sines on the other side. I am probably going to take this side right here and change everything to sine and cosine. Now, before I go any further, somebody somewhere is going to say, well, why can't I just cancel those and be done with it? Because exactly, they're added and subtracted, they're terms, so you can't cancel terms, so don't cancel them. Deal with them, okay? You gotta leave them there and deal with it. So I'm going to change everything to sine and cosine because I've got sines and cosines over here. So, cotangent with your quotient identity. And by the way, I'm going to use thetas instead of alphas because I like thetas better. Cotangent is cosine theta over sine theta. Minus cosecant is 1 over the sine of theta. Use my reciprocal identity. All divided by. All right, here's cotangent. It again is cosine theta over sine theta. Plus 1 over sine theta. Okay, so far? Look at the fractions on the top. They have the same denominator. So I can combine this into one fraction on the top, which will be cosine theta minus 1 over sine. all divided by cosine theta plus 1 over sine, because I had the same denominator in these two fractions. All right, now that you've got one fraction on top and one fraction on bottom, this is the keep, change, flip thing. Okay, so I'm going to keep cosine theta minus 1 over sine theta, keep that, change to multiplication and flip this over. All right, when you keep, change, flip, the signs cancel, and you're left with cosine theta minus 1 on the top and cosine theta plus 1 on the bottom. Is there a question about that? The algebra or anything right there? All right, I'm going to stop right here. I've got on this side, I've got everything, and I've got cosines over here. So now I'm going to come back over to this side, and I'm going to see if I can get only cosines over here. I need to try to relate them. So I need to come down here, and I need to see about getting rid of these of the sine. I want to get all cosines. Now, there's several things I see. First of all, this top is already in cosines, but the bottom is not. It is the sine squared. If we look at the Pythagorean identity, and I'll write it up here, sine squared theta plus cosine squared theta is equal to 1. I can rearrange this so that I get negative sine squared. If I subtract sine squared over there, then it becomes negative sine squared of theta. And I'm going to move the 1 over here, and that'll give me cosine squared theta minus 1. Does everybody see that? I moved that to make it negative, so then I got the 1 over here away from the sine. So now this thing can be replaced with cosine squared minus 1. Now, I agree, knowing some of this comes with experience. But the more you do this, the more you can see what happens and why you do certain things. All right, I'm getting somewhere, believe it or not, because I've got cosines over here, and I've got all cosines over here. Now, one of their other hints was that some of these might factor. Well, if I rearrange the order on this top one and put cosine squared theta minus 2 cosine theta plus 1, if I just rearrange the order, maybe you'll see what I'm fixing to do. All right, here's my scratch word. Factoring. Think back to algebra. If this were x squared minus 2x plus 1, if this were x squared minus 2x plus 1, then you're supposed to know how to factor this, because this would factor into x minus 1 times x minus 1, right? Because you could FOIL it back out and get this. Well, we don't have x's, we've got cosines, but it factors the exact same way. So we can factor it into cosine x minus 1 times cosine x minus 1 all over. Now this denominator, this is the difference of two squares. It is the same thing as having x squared minus 1. Do you remember how to factor the difference of squares? It factors into x minus 1 times x plus 1, difference of two squares. But instead of x's, we have cosine. So we have cosine x minus 1 times cosine x plus 1. Yeah. And since these are multiplied, you can cancel out. That one cancels with this one. Oops, and I've got x's, I'm sorry, instead of thetas. But I should have cosine theta minus 1 over cosine theta plus 1, and lo and behold, they match exactly, which is just what I needed to prove it. I know there's some of y'all that have not seen this before because you've not had Trig. And I think it's half and half. 2 of you have and 2 of you haven't. So I'm really talking to all of you, but particularly the ones that have never seen this before. First of all, do you have questions? And second of all, can I work another couple before I send you out of here? Perhaps? Okay, let me see what I can get over here. All right, this is out of your textbook. This is number 51. One over 1 minus sine theta plus 1 over 1 plus sine theta, and that's equal to 2 secant squared of theta. Okay, to me this is the more complicated side because I've got to add fractions. You need common denominators, right? The common denominator is both of these. Let me show you the quick way to get a common denominator. The common denominator is both of these, which is going to be, 1 minus sine, sorry. That's the common denominator. In this fraction, I'm going to multiply 1 plus sine, this one, times that. So 1 times that gives me 1 plus sine theta. Plus, bring your plus sign straight down, multiply this one times this one, and 1 times that is 1 minus sine theta. And now I have got a common denominator and one fraction all at one time. Dadgummit. It's not. Thank you. That's commonly called your hand and your mind and everything all not communicating. Yeah, sorry. Thank you. That'd be quite a trick, wouldn't it? Just change the sign to cosine just because? Yeah. Okay. Sorry. Everything should match, okay? All right, look at the top. Some of that stuff is probably going to cancel out. In fact, I see a plus sign and a minus sign. And a 1 and a 1 is going to give me a 2. Well, I know I'm making progress because I've at least got a 2 there. All right, on the denominator, I'm going to go ahead and FOIL that out. So that's going to be 1 plus sine theta minus sine theta minus sine squared of theta. Plus sine minus sine. That's going to give me 2 over 1 minus sine squared. Look where you're trying to go. You're trying to get a secant squared. What do you know about 1 minus sine squared? That is cosine squared. So this is 2 over cosine squared of theta. And cosine squared of theta in the denominator, the reciprocal of that is secant squared. So this is 2 secant squared. And that matches. Questions? Do I need to do another? Do you want me to give you some to try to work, or you just want to try to wing it on your homework? What does that look for? Do you need me to do some more? Yes, yes. I think there's one almost just like this one on your homework, except it may be cosines and there may be a minus sign here. So I think this is about as complicated as it gets. I don't think there are even any this complicated right here on your homework. I don't think there are. No. They're not complicated to me. I could do them all. Usually I can anyway. Yeah, people. All right. Do you have other questions?